Welcome everyone. I was in person last time, but I'm remote again. Last time we had version 120 release, which was really good. And since then, there's been already, 117 commits. But one of the interesting ones, which I just could talk about pretty quickly, is finally we merged ESP-NOW support. And thanks very much to Glenn, who is online here, for persisting with this for so long and keeping it up to date, and also taking on my feedback and review and making it what it is and getting it merged. So that was really good. And also to Nick and others who had initially worked on this. So it's been a long time coming. So I'm going to do a quick demo of how this works. I think it's a very simple and easy way to communicate between two ESP devices. ESP32 and 8266 works. And basically it allows you to send ad hoc Wi-Fi frames between devices. So normally when you use Wi-Fi and you connect to an access point, you associate your device, your station, with an access point, which has some handshaking and some sort of protocol and timing. And when you send an Ethernet packet, you have to send it to the access point, and then it gets routed to wherever it goes. So it's a star topology where the access point is the center of the star, or a spoke topology. With ESP-NOW, it's peer-to-peer, so you're just sending and receiving raw sort of Wi-Fi, not even Ethernet. It's even rawer than that. It's just vendor frames, and it can coexist with Wi-Fi connected to a Wi-Fi access point, which is great. But it does mean that you have to be constantly listening, which consumes more power. With normal Wi-Fi, you can have power saving mode and only wake up every, say, 100 milliseconds to listen for messages from the access point. But with ESP-NOW, if you don't want to miss messages, you have to be constantly listening. So that consumes more power. Of course, you can write an algorithm to, in your particular protocol or use of this, you could only wake up every now and then to listen. So yeah, it has some drawbacks, but it's also very low latency. And people, if you've played with a microbit and the radio module, it's kind of like that. You can just basically do send and receive packets, and I'll show how that works. There's some good documentation in the docs directory, which is also obviously online. Just easier to access the docs here, but it has a good introduction and overview and examples of how it works. So I'll show now. I have two devices connected. Whoop. That's not good. Both of them are ESP32s. So if I go to one, yep, this is an ESP32. And if I go to the other one, yep, that's another ESP32. So I have two ESP32s here. Can you see two terminals, hopefully? I assume so.
Yes.
And these are actually running with IDF5. So I did test ESP-NOW with IDF5 and it works, which is great. There was only a few minor changes that needed to be made. But all the tests that Glenn has written pass, which is good. So to use it, you have to you have network and ESP-NOW. So you have to create and activate the actual the access point itself, and then ESP-NOW also activate. Oops. So eNow equals ESP-NOW dot ESP-NOW and eNow dot activate. Okay, so now I have on one of them the it turned on. I got to do the same on the other. Okay, now we have to register our MAC address from one to the other. So the MAC address on the left we can get by doing config MAC. Okay, so and then I'm going to have to add a peer, add peer. Okay, so the right hand one is registered a peer. So we can now send packets. So if I send hello from the right hand one, and on the left receive, I get hello, which the message here. And also the first entry in this list is the MAC address of the sender. So if I look at the MAC address of the sender on the right hand side, it should match. So this MAC address should match this entry here, which it does. So that's very simple. You can see it's only a handful of lines, and we can already send from one to the other. We can also, well, you can send the other way, but I'm just showing you this one direction for now. Get a bit more information. So if we create a buffer to receive into, which has, you can use the receive into method, receive into buffer. Okay, so that's waiting for me to send. So if I send something, hello again. Okay, so now it just received it. This line on the left returned immediately as I sent the message. And the buffer now has, so you're receiving into, this is an in-place receive, so it doesn't need to allocate any memory. So into this object that I gave it, which contained these 4 elements, it stored the MAC address into the first byte array, the data into the second byte array, and then into the third and fourth elements was the RSSI, which is -3. These things are almost touching each other, I guess. And the timestamp in, I think, milliseconds. Now, that's useful, extra information, especially RSSI. Yeah, they're almost touching each other, these. If I do it again when they're a little bit further apart, -5, okay, they're still very close. I'll show a demo of them going further apart, but to do that, we can also register a callback. So on the left here, I'll define, say, a handler. And in this handler, we have it gets called whenever there's a new packet ready. So we can do receive into buff and then print buff. Okay, and then register that IRQ handler. Okay, so now anytime it receives a message, it's just going to call this handler immediately, so we don't have to do anything. So if we go to the right hand side and send something, as soon as I send it, it's printed out here, even though we're at the REPL. So we could go, say, import time and do for I in range a lot, print I, and sleep for a second. Okay, so that's sitting there doing something. Maybe it's in an async IO program or something else. And every time we send something, it'll print out the message that was sent. So I obviously can send something else. So if I now go in a loop on the right hand side here, maybe import time again.
Bitte? Was sagst du?
Is there any questions? So say we send a message every half a second. So on the right hand side, it's sending a message every half a second. On the left, it's printing out the messages. And if we separate the devices a bit so that they're not on top of each other, yeah, we can see that the RSSI is is increasing. So yeah, here's one of them. This is a tiny pico, and then there's another one. And they're as far apart now as I can get them, about 2 meters apart. And if I bring them close together, the RSSI should drop back. Yep. So you can see that's pretty simple to use. Send and receive, in-place receive, and callbacks. There is quite a few more features: encryption, async IO support, and you can get a list of peers table. Oh, that one doesn't have anything. That's interesting. So there's as I said, a few more features, and the docs are very good, so you can have a look there. I don't think AIO ESP-NOW is AIO ESP-NOW. Oh, it is. Okay, so that's good. The async IO version of ESP-NOW. I won't demo that, but you can play with that as well. So yeah, I think that's all I wanted to show. Again, well done to everyone involved to get this across the line, including Glenn. I think it's quite a good. It's a minimal API, but very functional, as you can see, and works now with IDF5. So when we update to IDF5, which hopefully will be soon, definitely for the next release, this will also work just as well as it did before.
Quick question, Damien. So on your right-hand terminal there, that's all true. There was 2 falses that came back. Was that packets that dropped, or? Yeah,
I believe so. I believe the return value there is no, we did not receive an acknowledgement. So when we're sending, by default, send is a synchronous send, and we'll wait for an acknowledgement from the receiver from the other side. Yeah, I mean, Glenn can clarify if I'm saying something wrong, but I believe true means yes, we got a response, and false means no. I was actually, when it said false, I was actually touching them, and I think I must have touched the antenna and it broke down for a moment. But
yeah, false is a drop packet or something like that, so it means the receiver hasn't received it. So
cool. And good old reliable wireless.
Well, it's yes, indeed. This is wireless, not Wi-Fi.
So one of the cool applications I saw of this was when Nick was originally doing this, he was using bottle rockets. And so it was really handy as the bottle rockets took off, he was sending telemetry data until they couldn't be received anymore. So that was interesting. Glenn, especially while you're there, what else have you heard of that this has been really useful for using?
Yeah, I think some people just use it for like some long-range communication. They've got devices in their sheds at the back of their farms and things like that. And one of the things I like it for is just as Damien was talking about before, you can start up a device out of deep sleep, send a packet, and shut it down again really quickly. So it saves enormous amounts of power for remote devices. So that was my interest, was the power savings.
I see, because it's so quick to bring up and shut down. Yeah.
Oh, it's enormous. If people hunt around, I've posted some where I did some power tests with the Nordic PPK2, and the difference compared to Wi-Fi it's huge difference in terms of the power consumption.
And you still got a long range, unlike Bluetooth, which is
yeah.
I have a question about the bytes. What are those last 2 numbers at the end of the list? Sorry if I missed it.
It's really hard to hear a bit about bytes.
When you receive into the buffer, there are 2 numbers at the end of the list. Oh, can you hear me?
Yeah, it's coming through actually right here. Come on.
So when you receive into the buffer, there are 2 numbers at the end of the list. Sorry if I missed it, but what do those mean?
Oh, sorry. the negative number is the RSSI, Received Signal Strength Indicator, of the remote device. So if you've got, so the RSSI tells you basically how strong the signal was when you received it. So when this message was received, this is the signal strength indicator in dBm of the signal. And then the second number, this number at the end is the timestamp in milliseconds. So you can see that these ones are about 500 milliseconds. In fact, that's 502 milliseconds after that. And that's because they were being sent every half a second. So that's a good indication that that's working. So that one's 509 milliseconds. Yeah, that's 505 milliseconds. So it's getting sent every half a second or just over half a second.
Awesome. Thank you.
Cool.
And it's worth sort of mentioning there as well, some of the possible uses of that is actually constructing a mesh network as well, using the RSSI to help with the mesh, sort of connecting capabilities. And there are some mesh, people have built some mesh on top of this as well, but there's nothing broad out there. So it's one of the useful things. And also tracking devices. So imagining tracking a device moving around a house, for example, by catching the RSSI from other devices.
Peter has a question.
Yeah, and what devices support this protocol? So obviously it says ESP-NOW. Is it restricted to just ESP devices?
Yeah,
Okay, so
good question. It is restricted to ESP devices because it's a very expressive, it's kind of an expressive proprietary idea / protocol. But that said, if you have a Wi-Fi sniffer, you probably can sniff these packets because they do conform, I think, to some protocol within Wi-Fi of being like a vendor extension packet that you're allowed to send. So it may be possible to receive them on other devices, but I don't know. Maybe Glenn knows.
Yes, it is. So Espressif do publish, they call it a vendor proprietary protocol because they use the vendor field in the action frame, but it is, they publish the details of that. So it's actually quite feasible to write it. And someone has done a port to the Raspberry Pi, for example. And I was thinking it might be useful. It would be an interesting thing to start to look at, which I started looking at about whether it'd be possible to do it on the Pico W or other devices like that. So we could get something that supports
Maybe
across other devices. You just need to be able to form the packet a bit. You've got to have enough access to be able to form the packet.
That's interesting. If people can do it on a Raspberry Pi normal, desktop PC thingy,
yeah,
the Wi-Fi chip in that is very similar to the Wi-Fi chip in the Pico W.
Yeah.
I'd be interested to see how they did that because we might be able to. Yeah, if we could make this work with the RP or Pico W, that'd be pretty cool.
Yeah, I think it'd be pretty useful. So long as you've got access, which I believe in the Pico W because you've got very low level access. You've got access to forming the structure of the packet. That would be really good.
Yeah.
Looking forward to trying it. What are you going to use it for, Matt?
I don't know.
You're going to make a mesh network of 400 devices?
I've got a lot of devices we can connect to, so yeah, we should do that as a project on that where everyone has an ESP-NOW. There's something with it. Yeah. Ooh.
All right.
You have any other questions, or should we let Damien and Glenn free? Do you want to go, or should I?
I'm pretty good.
If you want, I can always add another slide. Okay. Thanks, guys. I think Andrew's going to go. Yeah.